Hey, this is Math 8, Unit 4, Lesson 9. How much is in each group? Part 2. Let's practice dividing fractions in different situations. So first of all, we're going to begin with a number talk here called greater than 1 or less than 1. So we have some fractions here, and it wants to decide whether it's greater than 1 or less than 1. So before you do that, let's just think real quickly about just whole numbers you might be able to work with quickly. Alright, so if I had 4 divided by 2, is that going to be greater than 1 or less than 1? Well, 4 divided by 2 is equal to 2. So that's definitely going to be greater than 1. If I had 2 divided by 4, how about that one? Well, 2 divided by 4 is equal to 2/4, which is equal to a half. That is less than 1. So one thing we tend to see here is that when I have a large number, a big number, divided by a smaller number, I end up with something that is greater than 1. When I have a small number divided by a big number, I end up with something that is less than 1. Okay, so let's take a look at these fractions here. Here we have a half divided by a fourth. Which one of these is larger? Would you rather have half of a dollar or a fourth of a dollar? 50 cents or a quarter? This, in this case here, is a big number, right, divided by a small number. In which case, we're going to get something that is going to be greater than 1. In this one, we have 1 divided by 3/4. This is the big number divided by a small number, so that ends up being greater than 1. 2/3 and 7/8. Now that's tougher because you may not be able to tell which one is the larger number, right? They have different denominators, so it's hard to really compare them. We could kind of estimate that this is 7 out of 8, so it's really close to 8, where that, I know 2 out of 3 is close to 3, but this one's actually closer. We could prove that it is, but it actually is. So in this case, this is our smaller number, this is our big number, which means in total, this whole thing will be less than 1. And then over here, we have 2 and 7/8 and 2 and 3/5. Again, the 2's are the same. 7/8 is going to be closer to a whole number than 3/5 is going to be. So this is a big number divided by a small number, so it will be greater than 1. All right? And that's really what we're seeing, what we see going there. And that's the idea. Okay? Could we prove that with different things? We certainly could, right? If you came up here, if you think about this being a whole thing like this, and we're talking about a half, and a half is this one there, and we have 1/2, right? That's my half. And I ask you how many 1/4 are in, there? We have 1 1/4, and we have 2 1/4. So we can see that there's 2 of them in there, right? And that's what you end up with. So that one ends up being a little bit different, correct? So this one, let's think about this real quick without doing a crazy number. Let's do this. Let's draw 2 boxes like this. Okay? I'm going to divide them like this. And let's just, we're estimating here. If I do 8s, here's the half of 8, that's 4. Half of that's 4 there. So we cut those in half of there, and now I have 8s, right? So I have 7/8 over here. Let's just draw out 7/8 real quick. 7/8. And let's do 2/3. What's 2/3 going to be in here? Again, just estimating. It's going to be something like here and here. So there's my 2/3. Okay, so 2/3 is there. So what we're seeing, first of all, is that 7/8 is greater, is a bigger number than 2/3. Is all I want you to see there. That's how we were kind of able to estimate that out. Just to kind of visually see that it's a bigger number than what's in there. Okay, so when you talk about how many 7/8 are going to be inside of that, well, it's going to be a little, we don't even get a whole 70 inside of there, right? So it's less than 1. So we're asking how many groups of 7/8 are inside of here? Well, not even a whole one, because 7/8 is too big. Let's move on to the next one. Activity 2 says 2 water containers. After looking at these pictures, Lynn says, I see the fraction 2/5. Jada says, I see the fraction 3/4. What quantities are Lynn and Jada referring to? So Lynn is seeing 2/5, and Jada sees 3/4. What are they referring to in each situation? Okay, so on my picture here, I know it's a little hard to tell, but right there, this is approximately 3/4 of that container is filled, or a measuring cup. whatever you want to call it there. Okay, and over here we see we have 1, 2, 3, 4, 5 on that line there, so we're at about 2/5 here. So in terms of the 2/5, this might be the what the book refers to as the water dispenser. Is 2/5 filled, and this one here is going to be maybe my container. There's 3/4 water in the container, or the measuring container of some sort, whatever you want to call it here. So that's the container, and that's the water dispenser. The question is then on the next one, how many liters of water fit in the water dispenser? So how many liters of water fit into that water dispenser? What we can see is that we know that 3/4 fit into 2 of those, right? Which would mean we'd have another 3/4 here, oops. And then right here we end up with half of a 3/4 there. If we were to kind of just think about it in terms of addition terms, right? This is 3/4 of a liter based upon this picture. We would do another 3/4 to get 4/5 of it filled, and then I want half of 3/4 to get there. That's the idea. I'm really doing a 3/4 plus a 3/4 plus half of a 3/4 in order to find out how much water would fit in the entire container there. All right, that's the goal. So write a multiplication problem and to figure that out, and division to help you figure that out there. Okay, so as a multiplication problem, we might say something like, well, let's do division first of all. Let's do it because we like the division a little better so far in this chapter. So we're going to do 3/4 divided by 2/5 is going to tell me how much water is in the whole thing, right? Because we're trying to figure out how much water in the dispenser. Right now, I know I have 3/4 of a liter in 2/5 of the dispenser. So 3/4 is inside of 2/5, so that's our first problem there. As a multiplication problem, you could write down 2/5 times what number gets you 3/4. So let's go ahead and solve this real quick. I'm going to solve it right here in this space, just because I want to flip it over and change the picture and stuff, okay? So as a solution here, we would do 3/4 divided by 2/5 equals something we don't know. We're going to go ahead and we're going to multiply by the reciprocal. So in this case here, we end up with 15/8, right? And in terms of how much that's going to be, 8 goes into 15 one time with 7 left over. So I'm going to use 1 7/8 liters of water will fit inside of there. Okay? And again, just estimating here, we know that if I have 3/4 and 3/4, that's already 1.5, isn't it? Right? So I'm already at 1.5, so it's going to be greater than 1.5, and sure enough, 1 7/8 is greater than that. So that's where I end up with that solution. Okay? Alrighty, let's look at the next one. Activity number 3. Amount in one group. Write a multiplication equation and division equation and draw a diagram to represent the situation, then find the answer. Alright, so Jada bought 3.5 yards of fabric for $21. How much did each yard cost? So we're looking for the cost for 1 yard. So we're looking at a money divided by the yards. So in our case, we're talking about $21 divided by 3.5 for the division problem. The multiplication problem could be 3.5 times some amount would equal 21. Alright, so what are we talking about here? Well, in terms of the yard, we could think of this as, in our case, we're saying we have 3.5 yards of fabric, $21. We want how much per 1 yard is the idea. So let's take the fabric here. Let's do a yard. Let's do a yard. Let's do a yard. And let's do half of a yard to represent our 3.5 yards of fabric. Right, like that. We know that the whole thing, this whole amount here, is $21. Okay, so if I think about this as being halves, halves here would be half a yard, 1, 2, like so. So I end up with 7 halves of a yard. The reason I say 7 halves is because this could be rewritten as 21 divided by 7 halves. So that's what we're looking at there. So to solve this, we're going to use 21 times the reciprocal, 2/7. 7 goes into 21 3 times, and 3 times 2 is 6. And so what we're going to say is that 1 yard is going to cost us $6. Okay, so let's see if that actually works out to be accurate. So what we're saying here is that this would be $6 for 1 yard, and $6 for another yard, and $6 for another yard. 6 times 3 is 18, right? Is that about right? So we have $18 there, and then, am I doing this right here? Sorry about this, let me think about this. 18, 19, 20, 21, yeah. So then another 6 would be here for that amount there for the full, which is 24, but I'm only doing half of one, so I have a 3 and a 3, so I get my 21 by doing 6 plus 6 plus 6 and the half a yard to come up with 21. And that's the idea. Number 2. It says 4/9 kilogram of baking soda costs $2. So 4/9 kilograms baking soda, $2. How much does 1 kilogram cost? So looking at the cost for 1 kilogram. So what are we doing? We're taking the cost and dividing it by the kilogram. My cost right now is $2, and I'm dividing it by the kilogram, which is 4/9. And that's what I'm up to. As a multiplication, I might say 4/9 times something is going to equal 2. On our just doing the work here, we're going to say 2 times what? Multiply by the reciprocal. So 2 times 9/4. It's going to equal, and we can reduce on the diagonal if you choose to. If you don't want to do that, that's okay. So we have 2 goes into 4 2 times. 1 times 9 is 9, and 1 times 2 is 2. So we have 9/2, which is the same as 4.5. And because we're talking about money, that would be $4.50. Just like up here, I sort of said $6 there. How can we show that there? Well, let's show it this way. We know that 4/9 is a kilogram costs $2. That's what we know so far. So 4/9, let me think about this. 3, yep, okay. Let's go with ninths. 1, 2, 3, 1. So we're going to divide this into ninths. 1, 2, 1, 2, right? This is 3, this is 9 out, these are ninths. So we know that 4/9, which is going to be 1, 2, 3, 4. Let's go 4. That doesn't matter the color, but I'll do 4/9. I'll do a 4/9 here. So that is a 4/9. And 1, 2, 3, 4. That is a 4/9 there. And we know that each one of these costs $2, right? So this is $2. This is $2 for each of those sections. So already I'm at how much money? It's going to cost me $4. But I had this extra little section hanging out here. So what I'm trying to do is just on the graphic display, what is that amount going to be equal to? Well, that is 1 out of the 4. 1 out of the 1, 2, 3, 4 of a group. Now, does that mean it's worth a quarter? No, because the whole thing was worth 2, which meant that each one is a half, a half, a half, and a half. So really that's going to be equal to a half, which is 50 cents. Okay, but again, don't worry about that part there. Just want to kind of show you with a picture how that kind of worked out. So where you got that 50 cents from. And our next one says Diego here can fill 1 1/5 bottles with 3 liters of water. How many liters of water fill 1 bottle? So we're looking for how many liters for 1 bottle. Okay, what we know so far is we know how that we have 3 liters, and we're dividing that by 1 1/5 bottle. That's our division problem. As an addition, as a multiplication, we could do 1 1/5 times something equals 3. So we solve this. 5 times 1 is 5 plus 1 is 6. This is really 3 divided by 6/5. And then we will multiply by the reciprocal. I can reduce. 3 goes into 6 2 times, so I have 5/2, which is the same as 2 goes into 5 2 times, with the 1 left over, 2.5. And that's what we have shown right there. So let's just draw here real quick. I'm going to draw 2. I think here, let's go 2. Yeah. I'm going to draw 2 of these here. And because I'm going to show these are my water bottles, and I have 1 1/5 water bottles, so I'll make this into fifths. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And we know that we have 1 1/5 of a water bottle there. And that inside of that, we get a total of 3 liters inside of that. So the question we're trying to figure out is how many liters inside of one bottle. So how many liters inside of right here in this amount right there? That's our one bottle that I want to figure out. That's what we're trying to do. So in 3 liters, I get 1 1/5. So I'm going to have something less than 3 because that's 3. I want to get to here. So that's why it's going to be less than what I started with. So a little bit less there. So in this case here, because I'm doing 5 halves, we can see that by saying that it's 5 out of every 2. So we have halves here, and we have 1, 2, 3, 4, 5 of those, and those are all halves. Because if this is 3, we have 1, 2, and 3, and those are halves of that one. So 5 halves. All right, one more. 5/4 of a gallon of water, fill. So 5/4 of a gallon of water, fill 5/6 of a bucket. How many gallons of water fill a bucket? So we're looking at the gallons in a bucket. So our gallons here is 5/4 divided by the bucket, which is 5/6, and that's what we're looking for. Multiplication wise, we could say 5/6 times question mark equals 5/4. Let's go ahead and solve this here. This is 5/4 times the reciprocal, 6/5. The 5's cancel one another out, and we're left with 6/4, which reduces to 3/2, which reduces to 1 1/2. And if we want to draw a picture there, we certainly could. So we have 5/4 of a bucket. Okay, let's think about this. Let's go with 5 of these. 1, 2, 3, 4, 5. Right, and each one is 1/4 of a gallon. 1/4, 1/4, 1/4. So I have 5/4 altogether. Gallons of water, and that fills up 5/6 of the bucket. Okay, and we could say 1, 2, 3, 4, 5. All right, so we could say here, and that's going to be 5/6 of the bucket is there. So we need one more fourth there to get that all figured out. So we have a whole. That's a 1, 1, 2, 3, 4. Sorry, right there. That's 1. And then the fourth and a fourth is equal to the half. I could probably do a better job drawing that for you. Right, so let's just do it real quick. So 5/4 is this part. Here's my 5/4. We're asking how many 5/6 are in there. Okay, so out of our 5/6, we have a whole one. 5/6, sorry. 5/4. I drew my picture, didn't do the way I like to do it. Sorry. Let's just leave it like that for now and move on. Are you ready for more? I am not ready for more. Let's just go to our summary and we'll wrap this guy up. Sometimes we have to think carefully about how to solve a problem that involves multiplication and division. Diagrams and equations can help us. They can also sometimes slow you down a little bit too if you have to draw too many squares and boxes. So, take an example. 3/4 of a pound of rice fills 2/5 of a container. There are two whole amounts to keep track of, 1 whole pound and 1 whole container. The equations we write in the diagram will draw depend on what question we're trying to answer. And that's really the hard part here. Am I trying to figure out how many pounds are in 1 container or how many containers are in 1 pound? That question there is the most important part because it tells us how to set this division problem up, or multiplication problem if you want to, right? How many pounds fill 1, or how many containers does 1 pound fill? Those are two different questions there, which then become two different types of equations. So if I wanted to know how many pounds fill a whole container, this is pounds per container, right? Then I'm doing the pounds, which was the 3/4, divided by the container. So this is my pounds divided by the container amount. Okay, so on the picture here you can see that I have 2/5 of the whole container there, and that's what I have. And so in this case here, I have 3/4 of the pound contains that. I could look at that and say, well, if I take half of 3/4 just as a math kind of concept here. Half of 3/4 is going to be 3/8. It's 3/8, right? So that's 3/8, and I'm going to actually end up with 5 of those altogether because there's 5 of them. So if you think about a 3/8 times a 5, you end up with, oops, that's 5. You end up with 15/8. Now notice here real quick, what do you see? Oh, there it is. So if 2/5 of a container is filled with 3/4 pound, then 1/5 of the container is filled with half of 3/4, right? Half of 3/4, which is 3/8, or 3/8 of a pound. And then one whole container has 5 times that amount there, which is 15/8. Here we can represent the second question: what fraction of the container container 1 pound fills? Is the other way, which is 2/5 here is 3/4 of a pound. Notice if this is 3/4 of a pound, what do we have? Well, then that is going to be a 1/4 and a 1/4 and a 1/4, because a 1/4 pound fills a third of it, 1, 1, 1, leaving a fourth there, which tells me in this case here, I'm going to multiply that out, and we end up with, that's the whole pound there, and the whole container. So 3/4 of a pound fills 2/5 of a container, then 1/4 pound fills a third of 2/5, or 2/15 of a container. So 1 whole pound then fills 4 times 2.15 of a container. So that's the way that one works out. So anyways, just take some practice, take your time, draw a picture if you need to. We'll do some in the homework together, and let's give you time to work on that, and we'll see you in a minute. Alright, number 1 for homework. A group of friends is sharing 2.5 pounds of berries. If each friend received 5/4 of a pound of berries, how many friends are sharing the berries? Okay, so what we're doing is we're saying 2.5, I have 2.5 pounds of berries, right? And I'm dividing it into groups of 5/4 to find out how many groups there actually are going to be. So it's 2.5 divided by 5/4. 2.5 can be rewritten as a 5/2 divided by 5/4, because 2 times 2 is 4, plus 1 is 5. Now this problem here, what we learned, we can take the first one and keep it where it is, and then we're going to multiply by the reciprocal. Our 5's are going to cancel out, meaning we end up with 4/2. That reduces down to 2/1, which is the same as 2. So what we can say is that 2 friends are sharing the berries in that first example. If 5 friends are sharing the berries, how many pounds of berries does each friend receive? So now we're taking the 2.5 pounds and we're dividing it with 5 friends to find out how much each person's going to get. Again, 2.5 becomes 5/2 divided by 5. 5 is the same as 5/1. So let's rewrite this as multiplication. We would do 5/2 times the reciprocal, 1/5. The 5 is going to reduce to 1/1. 1 times 1 is 1, 2 times 1 is 2, and we end up with a half. Which, if you think about it, that makes sense, right? Because a half for each person, and I have 5 people, that's 1 whole, 2 whole, and a half, 2.5. So that's my 5 people, and they each get half a pound there. Number 2, 2/5 kilogram of soil fills 1/3 of a container. So 2/5 soil, 1/3 container. Can 1 kilogram of soil fit in the container? That's the question. Can 1 kilogram fit inside of there? Well, if I have 2/5, and I am dividing it by 1/3, right? 2/5 times 1/3. In this case here, this is a big number divided by a smaller number. And when we do a big number divided by a small number, we end up with something that is going to be greater than 1. So, will we have enough to fill up will a whole kilogram fill a container? Sure it will. What we're saying is that because I have 2/5 in 1/3, I'm going to have a 2/5 and 1/3 of it. So here's 1/3 of a container, and another third, right? And I have 3 of these, and another third. Because I have a third, I have 1, 2, 3. If we draw it as a picture like so, here's my thirds of a container, and everybody has 2/5 inside of it, and the whole thing is 3 parts. So it's 2/5 times 3, 2/5 times 3, which is 6/5, and that is more than 1. That's 1 and 1/5. So I'm going to be able to fill up a container and have a little extra to go around. Number 3. After raining for 3/4 of an hour, a rain gauge is 2/5 filled. If it continues to rain at that rate for 15 more minutes, what fraction of the rain gauge will be filled? To help you answer the question, Diego wrote the division equation. 3/4 divided by 2/5 equals what? Explain why this equation does not represent the situation. Well, why won't that quite work? Well, what he's doing is he's saying how many 2/5. If he's done 3/4 of an hour in there, what we have is we have 2/5 like this, 2/5, and he's saying, okay, I've done 2/5 of it, and we have after 3/4 of an hour, 2/5 of the gauge is filled. There's our little picture there, right? So that's how much is filled after 3/4 of an hour. We're going to go one more or 15 more minutes, so another 1/4 hour, which I don't have here, but we're going to be adding on to that though to make a little more. So it's 2/5. Really, it should be 2/5 divided by 3/4, because what he's doing here is we want to divide how much rain and time, because we want to say the rate for how much water in an hour is our goal. So we have to look at the water, which is the 2/5, divided by the water, which is the hour, which is there. So that's the actual equation. We want to look at how much water in an hour. So now this one then becomes 2/5 times 4/3, which becomes 8/15 is what you'd end up having there. Right, multiplication division problem, well, we kind of did both of those. We would do 2/5 divided by 3/4 equals something. And we also could do 3/4 times something equals 2/5. So you just want to think through it a little bit. Like, it's just what he's trying to do didn't quite make sense because he was doing a little bit backwards. So look at what they're asking you to do. Number 4. 3 tickets to the museum cost $12.75. At this rate, what is the cost of 1 ticket and 5 tickets? So we're looking for the cost for 1 ticket, right? And right now, what do we know? We know that it is currently $12.75 for 3 tickets, or 12.75 divided by 3. That's going to equal $4.25 for 1 ticket. You just do the math there. 3 goes into that, 4.25. For 5 tickets, then I take the $4.25 and I'm going to multiply it by 5 to come up with $21.25 is what it would cost me for 5 tickets there. All right. Number 5 is also a review question. It says Elena went 60 meters in 15 seconds. Noah went 50 meters in 10 seconds. Elena and Noah both moved at a constant speed. How far did Elena go in 1 second? Noah in 1 second. Okay. Well, so for Elena, she went 60 meters in 15 seconds. So to figure out how much that is in 1, I'm going to do 60 divided by 15, which is going to be 4. And so I know that he's going to go 4 meters per second. And for Noah, or she is, Noah's going to go, he went 50 meters in 10 seconds. So divided by 50 divided by 10 is 5 meters per second. So in terms of who went faster, we would say that Noah did, because Noah went 5 meters per second based upon the ratio we created right there. And number 6, the first row on the table shows a recipe for 1 batch of trail mix. Complete the remaining rows with recipes for 2, 3, and 4 batches of the same type of trail mix. All right, so in 1 batch, there are 2 cups of cereal. So in 2 batches, we're going to double that up, right? So 2 times 2, we're going to say 4. And instead of 1/3, we do 1/3 times 2, which is 2/3, and 1/4 times 2 is 2/4, or we could say that's a half. For 3 batches, we do it times 3. 2 times 3 is 6 cups. 1/3 times a third is 3/3, which is the same as 1. And 3 times 1/4 is 3/4 of a cup of raisins. And finally, 2 times 8 for 4 batches is 8 cups of cereal. And then 4/3, 4/3 cups of almonds. And we have 4/4 here, which is 1 cup of raisins. All right, just doing that multiplication this way to get that answer right there. And again, with each of the other ones is the idea. That's it for today. Have a great day. We'll see you next time.